How else would you learn? Let it crash.
Exactly. The best things happen when things fail. Seriously. If it's in a controlled way, right? I think that's like something which isn't said, it's implied. It has to be a controlled failure where you have the boundary and things will not blow up. I mean, they'll blow up, but like, like the fireworks sort of blowing up, where it's a controlled explosion.
Yeah.
Right. Tiny little crashes to learn from. Welcome everyone to Kaizen 22 with the incomparable Gerhard Lazu. He's here to let us know how he lets it crash. It's like that song, Let It Snow, Let It Snow, Let It Snow. Only you know how to replace. Hey, Gerhard, how are you?
Hey, Jerod. I'm good. Thank you. Had a great holiday. It was a great couple of weeks where I've managed to finally disconnect. It's been, I don't know, like 20 years since I had 2 weeks completely off. Nice. Even my holidays are only a week. So this was very different, very enjoyable, and I feel so refreshed. So I'm firing on all cylinders.
You unplugged, and now you're plugged back in.
Pretty much.
Plug it in.
I stopped it, and I started it, and it's like brand new.
It's like Glade, man. I'm like Glade over here, man. Plug it in. You know what I'm saying? Smell the scent, the fresh New Year's scent. Called 2026, where
some people are going to say this is going to be the best year ever. I've heard it said. What do you think?
They keep saying that, and I'm excited about them.
They said that about 2020.
2020, we have to admit, it was off to a killer start. I mean, it was really going well.
Right. Pun intended. Killer start.
What happened in 2020?
It was COVID. Pun intended. Killer start. That was 2020. Yes. 2020 was the year of COVID, and everyone's like, "Oh, this is going to be like the best year ever." And then we had 3 years of misery. So I think,
put it behind us.
I just want like an easygoing year. You know what I mean? Last year, 2025, 1st of January, we were building shelves. We were like redoing like studies and whatnot, and the whole year was full on. Like it was nonstop. Every week there was something significant happening. And this year would for it to be a bit more chill, maybe a bit more meaningful. So that's what we were thinking. But how about you, Adam? How are your holidays?
My holidays were filled with barbecue and good times.
Wow. Even in winter. So barbecue never stops. It doesn't know seasons.
It never stops in Texas. Actually, just to shower you all with a few of my picks from my most recent barbecue adventures. If you're in Zulip, go to the general channel, look for barbecue with 3 bangs after it, because why do 1 bang when you can do 3?
Bang, bang, bang.
Some recent ribs. My gosh, my ribs method is on point. My spatchcock chicken method is on point. No one is disappointed at my barbecue joint.
Very nice. Look at that. We're going to add some meat on this slide. That's what happened in real time.
Wow. Real time meat added. This is like, this is intense.
And that's, again, just to be clear, it's Adam's barbecue. Okay, so like no joking aside, we're talking about barbecue.
Yeah,
I think we have to leave it there.
Let's move on.
I think we have to leave it there.
I didn't show a burger, but I do make a mean burger too. Thank you, Gerhard, for assuming that is something I do rock really good. My smash burgers are on point.
Very nice, very nice. I'm looking forward to that. So
one day.
My favorite Christmas tree. This is what it looked like.
What is that?
And for those that are listening, it's a networking cabinet. There's lots of blue lights flashing. This is happening in the loft. You have many terabits of network throughput. There's some switches, there's Unified, there's MikroTik. This is maybe 5 years in the works. And every Christmas, I take time to improve it little by little. So this year I went really crazy. I redid like the whole thing. I redid like the whole, for example, DHCP network, VLAN. Oh man, it's beautiful.
Your VLANs are beautiful.
They are.
I want to be a guest on your network, man. I'm going to get blocked from everything. Okay.
Yeah. Well, there's like a big story happening in the background, and it is going to be, I think, this year amazing. This will be the best network that I have run like in my life. But the blue and the darkness, and it's like that was like one more Christmas tree in our house, and this was it, where I would just go and tinker for a few hours in between Christmas dinner and, all the Christmas festivities. Mm-hmm. So it was nice just to spend a bit of time tinkering with hardware. And I'm sure that many of you listening, when it comes Christmas time, when things start quietening down, you get like the little projects that you didn't have time for throughout the year. And then you have some fun. So I'm wondering, did any of you do anything fun this Christmas, but nerdy fun? That's what I mean by that.
Nerdy fun. Well, I got upset with something.
That's not fun.
And so I decided to just let it roll. You know what I'm trying to say? I got upset with the amount of RAM usage on my machine. And while I like the application, I was like, you know what? I'm just kind of tired of having 4 gig. I think it was like 1.2 gigs of RAM being used by Clean My Mac. Mm-hmm. Fancy little utility application, helps you tune and pay attention and stuff like that. And I decided to remake it. And that was it. So I remade it. It's called MacTuner. I know there used to be a MacTuner.com, which was, I think, a Mac magazine, I believe. But MacTuner fit. I might change it. Who knows? But for now, it's called MacTuner. It does all the things. All the things. Analyze, clean up, uninstall. And not just that fake uninstall, the real one, where you get the dirties out. You know what I'm saying? The dirties. Oh, yeah. All the dirties are out. Okay.
My mind is still on the dirty burger that you mentioned earlier.
Yeah.
I mean, that's about as nerdy as I can get. I mean, I made a little utility that's for me for now. Soon to be open source, though. Soon to be.
It will be soon.
Yeah.
Very nice.
I mean, why not, right? Share with the world.
Well, I didn't create a Mac tuner, but I found one. I also was thinking, clean my Mac, like how long am I going to run this thing? And the answer is as long as I ran it, because I'm done now. I found a tool called Mole, M-O-L-E, which is a command line Mac OS cleaner that does like everything. So you maybe got some competition here at it. Maybe you can come out and like throw some blows down. Like, here's why I'm better than Mole. It's got TUI. It's all command line based. It does cleaning, optimizing, uninstalling, Daisy Disk, Explorer.
Oh gosh.
All from,
I'm feeling it. I'm feeling intimidated over here.
Starting to sweat? You starting to sweat?
Well, I think he just changed his mind about open sourcing it.
Here's your domain name idea, Adam. Betterthanmole.com. Better than grep.
That's good. I could do that.
So I've been using that. I've been very excited because who doesn't want to just have all the things right there in their command line? And I didn't spend any tokens on it. Adam's got some tokens involved, but his also works the exact way he wants it to.
Yeah. Yeah, absolutely. Mine leverages some recast stuff as well. It's kind of cool.
Sweet. Open source that sucker.
One day.
Which day is that?
Not today. Definitely not right now.
But it's going to be a one day is what it's going to take.
One day. There's a bigger launch awaiting, is all I'll say. There's a bigger launch awaiting till I'm going to open source some things.
Been using App Cleaner for many, many years. There's no TUI, there's no CLI. It's just like a regular app. It's a really old one.
Yeah. Which you like drag and drop onto it, right?
Pretty much, yeah. And you also have a list of applications. But it's so old that it's difficult to find it these days. And it hasn't updated in a very long time. So I will check Mole out.
Mole's really cool. Install Mole and you're done. So you can check it out right here while we're talking. And I liked App Zapper. And I think App Zapper doesn't exist anymore. But the cool thing about that was is that it would literally make the zap sound as it, you drop your app on and it zapped it. And I just like that sound.
That's the only feature that your application needs to have, Adam. If it zaps.
Mole does not zap. So there you go.
Make it zap is our tagline, actually. Make it zap.
Make it zap.
There you go. I think that's a very good debate, actually. Everything.
What about you, Gerhard? Besides your Christmas tree,
I will come back to that. I will come back to the Christmas tree.
This guy's got stories, man.
Oh, man. Oh, yes. It's like I have to tease them and be very disciplined because there's too much stuff. Yeah. So I have to be very careful because it will be an hour and I will not shut up talking about this thing. I mean, it's just like, anyway. So we will come back to that, I promise.
Okay.
Last time when we finished Kaizen 21, this was one of the last thoughts that we shared, which is what's next. So BAM. Remember BAM? That happened live. OOM crashes, out of memory crashes, and a bunch of other things. The good news is that only one thing happened. OOM
we only
crashes.
got one thing to talk about.
But this rabbit hole is really, really deep.
Okay. All right, take us down the rabbit hole. The OOM, out of memory.
Who remembers this book? Erlang in Anger.
Erlang in Anger.
Stuff Goes Bad by Fred Hebert. Ferd.ca.
Now, I remember learning to use some Erlang for great good, but I do not remember this one in particular. So I'm not sure why the other one hit my radar, because he wrote both of them, it seems. But when did this one come out?
Wow.
So this one, if I look, I just switched to the browser 2016, 2017, while he was still at Heroku. Remember Heroku? Those were the days. So about 10 years ago. And Fred, I mean, he just like, if you don't know his blog, I mean, it's just amazing. I'll just click it very quickly just to have a look. Oh, I think it's one of the best blogs out there. There's so much goodness here. So much. But one of my favorites is queues and queuing and how queues don't protect from overload. So queues don't fix overload. And this is so relevant to today's conversation as well. But there's a lot of stuff in the Erlang ecosystem, and there's many, many things that Ferd wrote over the years that are so relevant to today. So if I click on download PDF, right? By the way, this is like it's amazing. This book is open source. You can download it, open source, freely available, Creative Commons license. And I'm going to make this a little bit bigger so we can see what's happening. And if I search for Let It Crash, it's page number 1. It's in the introduction.
Page 1.
Page 1. And this idea of Let It Crash really comes from the Erlang ecosystem. It's very well renowned there because of how the Erlang VM works and how all the processes and the supervision trees, it was built this way. And we know a thing or two about Erlang, Jerod, right? Because the application, Elixir, the Phoenix framework, runs on the same principle.
I know a thing and you know two. So that's how we get to a thing or two.
And Adam, I'm sure he knows the big one. But we don't know whether he's going to share it. The point is, when you think about Let It Crash, Jerod,
yes,
in your, from your development experience with Erlang, with Elixir, Phoenix, is there any situation, any moment where you could experience it and you realized, that's nice?
When I let it crash.
When you let it crash.
Well, it's nice that the beam seems to handle a lot of the problems with letting it crash. You know, it just goes again, or there's a supervision tree and things watching each other. Yeah. And I don't have to think about it very much. I can't think of like an instance in development where I was like, this is really useful, but I'm sure you could come up with one.
Yeah. So, when you write code, we tend to write code very defensively, typically try catch. So you feel like you need to account for every single scenario. And the let it crash philosophy is about not preventing failure, learning from it. And what it means is you need to have a context where it's safe for things to crash and the overall system will still remain stable. So how can you build a resilient system? And really this is about resiliency, where the core of the system will remain running and the system as a whole will remain running, even though parts of it may experience failures. But those failures will not bring everything down. And that's really important. So fewer try catch blocks, don't code defensively, let it crash, and separate the code that solves the problem from the code that fixes the failures. And the more you can lean into the framework or the VM or whatever you have, the system to deal with failures, the better off you are to focus on the things that are unique to your application.
Yeah.
And Erlang is well renowned for that.
Kind of the opposite philosophy that Go took as I write some Go code and I write some Elixir code, where with Go, it's like handle every error condition right after you potentially raise one and make sure that there's no error. And if you're not dealing with it, then you're not writing robust software. And the other philosophy is let it crash and deal with it elsewhere. I think they're both legitimate depending on what you're building.
Agreed. Well, in our case, we had a lot of crashes to deal with.
Yeah, we're taking the Erlang style.
So what we are going to have a look at is all the times that the Pipedream has been crashing since our last Kaizen. So since Kaizen 2021, which is October 17th, we had a lot of crashes. And there's a certain property about the system, and this is Varnish specifically, that made these crashes pretty okay. And the property which I'm referring to is when you start the varnish D, the daemon, varnish itself runs as a thread, and you have many, many threads that do different things. So when we had these out-of-memory crashes, all that happened, the thread was killed, which means that the system as a whole didn't crash, the VM didn't, the Firecracker VM didn't crash, the application needed to restart. It was just a thread that was using too much memory, and it restarted within seconds. As in maybe 2 seconds and everything was back to normal. Obviously the cache was cold, but it was good. I mean, the VM, and that's why the memory looked a bit interesting in that it doesn't release all the memory. The VM doesn't restart. There's not many hangs. It restarts and it crashes really, really quickly. So that's a nice property.
Well, that confuses me. So how does Fly know about it then, if it's just happening inside of Varnish?
So it's looking at the process. It has looking at the process ID, which process uses the most memory, and it's the same process that's asking for more memory. So it just basically it will just send a signal to that process and kill that process. But that is just a thread that maps to a thread. So Varnish itself didn't crash. It's just a thread that maps to a process ID that crashed. And then it was restarted by the Varnish daemon.
Okay, so where is Fly involved in that? Because Fly is aware because I see all these Fly notices and I get the Fly emails.
Right. So Fly is aware that there's a process on the machine that is using too much memory and more memory is being requested. And then it looks like, okay, which process do I kill? And in this case, the process with the most memory will get shot and will get killed.
Fly as a platform can actually reach it and kill that process without killing the machine, rebooting the VM or the Firecracker or whatever.
So the Fly platform, it integrates with that functionality, which is a kernel. It's a Linux functionality, right? That's why like an out-of-memory crash would happen even like if you have a single machine, you have too much memory, you don't have any swap. How do you basically give more memory when there's no memory left and when the system is becoming unstable? So then you get like just a single process which gets killed. In Fly's case, they surface that. They surface the fact that there was like an out-of-memory crash, there was an out-of-memory event, and they send you an email when that happens. It doesn't mean that the machine had to restart. It doesn't mean that he stopped serving traffic. It just means there was like something that just had to go away because it was using too much memory. When I say too much memory, it's a bit more complicated than that because something was asking for memory. The kernel didn't have any more memory to allocate, so it was just had to look at what needs to be killed so that I can allocate more memory because something is using too much memory. And it just so happens it would be this process and this thread. So how many crashes do you think that the Pipedream had since Kaizen 2021? Since October. So we're talking about 3 months, maybe a bit more than that.
So Gerhard has presented us a multiple choice quiz. A is 20, B is 40, C is 80, D is 160. Now I know that I personally receive an email every time this happens. Mm-hmm. And so I have a little bit of a feeler into this. I delete them, so I can't go do a quick search. Adam, do you get emails when these Fly things crash?
I don't.
Okay, good for you.
Not to my knowledge, and if I do, they're in a box that doesn't get looked at.
You've been saving on some email bandwidth.
I do know because when we send the email, so let's go back to this one. If I click on this one, let's take this one, and you can see everyone that gets an email. So I'm just going to make this a little bit bigger. So you can see services, Jerod, Adam, and Gerhard.
I do get it.
So there must be a filter.
He just doesn't look at it.
Superhuman saving me. Nice.
That's okay. So what do we think?
Good thing other people are looking at it. So
it's not an Adam problem. That's the thing. So that's a good thing. He's doing the right thing. He's just saving his inbox for more important messages.
They ran an LLM on that to decide. So I feel like 160 is too many. Mm-hmm. I don't think I've gotten 160 emails since October on this particular thread. Mm-hmm. 20 feels like not enough. I've certainly gotten more than 20 emails. Mm-hmm. So I'm between 40 and 80. And I'm going to think that, gosh, that's a tough one. I'm going to go with 40. Adam, what do you think?
I'd go with 40 as well.
Oh, I got it. Yes.
43 exactly.
The price is right.
The price is right. Mm-hmm. All right, cool.
Yeah.
43 crashes from October to December through the end of the year. Roughly.
Yeah. And obviously there were like periods when we had quite a few. So if we were to think about what could be happening in Varnish that it's running out of memory and crashing. So this is us trying to think about the sort of traffic that we serve, trying to think about everything. I mean, now we see every single request that hits changelog, the CDN as well, and it's a lot of requests.
Yeah.
So there's something in the system. There was something in the system that was using way too much memory. And as a result, the process, or the thread in this case, was crashing.
I mean, I could guess it, but I might even have some insight. So should I just say it, or do you want to add on a guess? I mean, my guess, based on, also I saw some emails flying through, but already I would have suspected that we just have too many large files.
Yeah.
These 60 to 80 to 100 megabyte MP3 files loaded into memory, flying every which direction. And you just can't load up that much memory without some sort of fancy freeing mechanism. And it's just trying to hold all these MP3s in RAM, I think, and I just can't do it. Mm-hmm. So that's my guess.
Yeah, that was a good guess. And I think the next question is going to be to the audience because we know too much.
How are they going to answer it? It's not real time.
Well, just think about it. Like we will give some time for people to think.
We'll do like a delay here. So if they have, what's it called? The feature where you pause silence, you skip silences on, they're not going to have any time to think about this.
Right. Okay.
So quickly turn that feature off. Give yourself some time to think. Go ahead.
Yeah, or pause. We can also say pause. Now is a good time to pause. And then what could be the problem? So you're right. All those large files, we had all the MP3 files, many, many MP3 files. They're large, all trying to be cached in memory. And that was a problem. So what is many? Well, we have thousands at this point of MP3 files across all the podcasts, like since the beginning of time. Large means anywhere from 30 to 40 megabytes to 100 plus megabytes. So that's, I mean, just think if you had to load 1,000 files that take 100 megabytes, that's a lot of memory that you need to have available. And the problem is that once you store these large files, as we discovered, you get memory fragmentation. In that, imagine that you have all the memory available, you keep storing all these files, and at some point, there's no more memory left. So what do? Well, you need to see what can you evict from memory so that you can store the new file. So imagine that you evict a few of those objects, but maybe they aren't big enough, and you haven't evicted them fast enough. So then you have like this big file that can't fit anywhere because the sizes, like the holes that you have in memory, aren't big enough for this file to fit. And there's no defragmentation or nothing like that runs in the background, which means that even though technically you kind of would have space in the memory, for the specific files you may not. And then it can't be stored in memory. Now the thing in Varnish is actually called, I kid you not, N_LRU_nuked. So nice. I think the connection to the nuke and to the book and to let it crash is right there. So LRU nuked basically, it's like a forced eviction. So it's an event where an object has to be evicted from the cache just to make room for a new one because the storage is full. So you can see how many times this has happened. And that's like an important metric that if we look at, we can see we had too many of these events, right? Like many objects were being nuked from memory to make room for new objects, but sometimes they wouldn't fit. So how badly did it nuke? Because we can measure this, we can look at this, and this is what it looks like from a memory perspective. So you can see that the instance was running about maybe 4 gigs of memory, and then we had a massive spike within minutes, like 1 or 2 minutes, to 16 gigabytes. So that's a lot of data that had to be fit in memory. And you can already see where this is going. Scrapers and bots and LLMs, and we have so many things happening. And then you can see the memory, it went up, the thread was killed, the child was killed, like the Varnish wants the memory came down again, and then it went up again. So the graph that we see here, we can see the first spike, just like maybe a minute apart. The second spike, another crash. It took a little while for it to restore. We're talking maybe 10 seconds. And then we stabilized around 10 gigabytes. From a CPU perspective, we got like 100% CPU utilization when this happens. Like everything is full on, everything like the instance is really struggling to allocate and deallocate and free up memory. And more importantly, we have a lot of traffic flowing through. So how much? 2.29 gigabits, specifically 2.29 gigabits
per second.
Exactly. And these happen so quickly, have like a huge rush of traffic coming in, and then nothing. So why is more traffic coming into the instance than going out? So this is the traffic that the instance is receiving. So we're receiving 2.29 gigabits, but we're only sending 145 megabits. Now is a good time to pause and think about why this is happening.
Yeah, don't skip silence. So when we say the instance, we mean the Varnish instance.
The Varnish instance, yeah. Like the
which sits between our end user, whatever that is, or users, and our application.
Yeah.
Well, actually, and our Cloudflare, not our application.
All our backends, and we have a couple of backends.
Yes, but in the case of MP3 files, it's our
Cloudflare R2
origin. So
that's correct.
Varnish is receiving a bunch of data and sending back significantly, an order of magnitude less data.
Mm-hmm.
And what's it receiving? I don't know, man. I mean, my guess would be like we're uploading MP3s. Now that's gonna go straight through the app to R2. Just a DDoS? I mean, what is it? I don't know.
Yeah. So it is a DDoS, but it's specifically downloading MP3 files or starting to download MP3 files, but never finishing.
Hanging.
Right? So you get like all these requests for MP3 files for large files. Varnish is going and fetching them as quickly as it can. So pulling all this data in so it has in memory, but the client is never around long enough.
Yeah.
Exactly. So they basically abort, but Varnish is still pulling it in all the data. Now, there is a property. It's called bresp.doStreamTrue. So what this does, very weird thing, it tells Varnish not to buffer the entire backend response if the client is slow, right? So I'm not going to fetch the entire MP3 file if you only want the first, minute or two or a range or something like that. Now, this is on by default. So by default, that's how Varnish behaves. So we wouldn't need to enable this. But if the object is uncacheable, it cannot be stored in cache. You see where I'm going with this? Memory, you can't store it in memory. So you keep pulling these files over and over again, and maybe even just fragments of them. So even though the client never receives them, you may be pulling hundreds of files and the client just goes away. So you're not pulling the entire file, but you're still pulling enough and not able to fit it anywhere and just becomes a mess.
This reminds me of the 90s when you used to go jean shopping, right? And you'd go into
tell us, tell us,
Abercrombie and Fitch, which I would never shop at. But let's just imagine I did, right? I'd go in there and be like, I like all these jeans, get them all. I'm trying them all on, and I just bounced.
Yeah, the person goes to collect them all. They come back, and you're not there.
Here's the dressing room full of jeans, and Adam's gone. Bye bye, see ya.
This really sounds like you're speaking from experience. Was this a prank?
I just made it up just now. I'm just creative like that. On the fly, creativity.
Wow, that's a good one. On the fly, yes. So
it is on the fly.
There it is. On the fly.io. Boom.
Well, what could we do then? What's going on here?
Exactly. So this was one of the things which I had to deep dive and understand what on earth is going on. Like, where do we store? Like, what's happening? So there's a lot more that went into this pull request. It's pull request 44. I'm calling it the elephant in the room. I'm going to switch to the browser just to have a look at that. So the title of the pull request is storing MP3 files in the file cache. But that's like the tip, right? Like the most obvious thing is, well, you either have lots and lots of memory to give Varnish, which honestly would be impractical in the sense that would be way too expensive to store all these files in memory. The next best thing is to have something like a file cache. And by the way, we're talking about open source Varnish. That's really important. Like anyone can use this. Anyone can configure this. You can configure a file cache, which will basically pre-allocate a file on disk. And that's where these large files will be stored. Pull request 44, the one that we're looking at, it's in the Pipedream repository. That's what this adds. But there's significantly more stuff. And if I'm going to, let me go, there's quite a few files. I highlighted a few, so I'm going to look at this one. So it's not just that. You also need to tune, for example, thread pools. You need to tune the minimum, the maximum. You need to tune the workspace backend, like how many memory structures get allocated. You need to configure the nuke limit. And there's a couple more things that we had to go through just to make things stable. Now, I'm just going to very quickly mention these things. You can go and have a look at pull requests to see what else went into it. So this was the one file. The other one was the regions. That's another thing. Not all regions would suffer from this. So you don't want to allocate too much memory or too much CPU to regions where maybe they don't get a lot of traffic. And you would think that this thing is easy. But oh man, I have a surprise for you. You can't mix and match sizes easily in Fly. So you can't say, create like application groups, and this group will be like the small group, and that group will be the big group,
Really?
and this is just one application. It's not straightforward. So you have to, again, this is how I solved it. Maybe someone listening to this will tell me, hey, Gerhard, you're wrong. I would love to know that, seriously.
Mm-hmm. Yeah.
So the way I solved it is we deploy in all the regions, right? Because you specify the size once. So you say my starting size is the large instance type. It has a certain number of cores, certain number of memory. And by the way, the disk is the same in all of them because that's like another problem. So we will sidebar that or put a pin in that. So when it comes to the initial deployment, you deploy the one size across all the application instances. And then you go and need to check to see which instances should be scaled down so that you have the capacity, but the regions that don't need the capacity, you can just bring them down. And you do like a rolling deploy in that you replace one for one. You have plenty of capacity to handle the traffic while instances are being rolled, all that good stuff. But we have hot regions and we have cold regions. And there's quite a few things here. Again, if someone knows how to do this better, I would love to hear about that. And we have the TOML, we have the primary region. There's a couple of things here. We'll come back to services and HTTP services. That's a fun one. We'll leave that for a little bit later. Fly just. We can see how we do the flyctl deploy. We disable HA because we want only one instance per region. We have 15 regions in total. We specify the CPUs, the memory, all that good stuff, including environment variables. Oh, that's another thing. We need to adjust the varnish size based on the memory the instance has, right? We need to say like, hey, varnish, you get 70%. And that's the other thing that this does. Same thing for the file size. You can't take up the entire disk. We tell you, based on the disk that we provision, how much space you should use from the disk that gets created. There's a scaling there, so that's another good one. I'm going through pull requests. There's anything else? Oh man, this was a pain. So recreating, like writing tests for this. Everything is tested in the sense that which requests would go, or which files would get cached in the file store and which files would be cached in the memory store. So how do you write the test? Some varnish logging is included. You have to have anchors. There's quite a few things. So that's assets backend.vtc. And part of this, it was a huge refactoring. So if you look at the lines of code, I wouldn't say it's that many. 1,500 were added and 1,470 were deleted. So not much changed. I mean, the net is 30 new lines were added. But there was like a huge, massive refactoring part of this. So there's, again, this was, I think, 2-3 days of like figuring it out, trying things, refactoring things. And if you think that an LLM can help you, well, you try this. And it takes longer to go through those iterations than if you know what you're looking for, it tends to be easier. Anyway, it's very dense, very specific, very difficult to make sure that it's doing the right thing. But it's all there. We have the mock backends. We're reusing things. We split the VCLs. By the way, we finish like the split, so it's easier to reuse them. So there's quite a few things there. Now, this is Kaizen. So we are wondering what improved. After all this work, right? We rolled it out, what improved? And to answer this question, we need to figure out which region is the busiest one. So out of all the regions that we serve, we have 15 in total. Which ones get the most traffic is those hot regions. We're looking at the Fly, the Grafana dashboard for our Fly application, the instance of the Pipedream, the current one. And we can see that SJC, San Jose, California, is a red, nice big red circle, which means it has the most traffic. And also NRT, which is Tokyo. Apparently.
We're big in Japan.
Yeah. And Europe, there's quite a few. So if I'm going to pull this down a little bit, let's see. No, I wanted to go
what about
here.
that new continent? Are we big there?
The new continent? Australia?
Oh, there's a new one. There's a new one.
Well, what's it called?
Which is a new one?
I don't know. There's a headline I heard. I thought y'all would get the joke.
No.
Over the holiday, there was speculation there was a new continent being announced.
Narnia?
Maybe. Could have been Narnia.
No.
With the closet.
Right now, if even this list is basically, if you think about it, it kind of makes sense, right? It's US East, US West, Europe, but we have quite a few instances in Europe. We have 4. It's more geographically spread in Europe, and we have Asia. So these are like the big ones. Australia, Africa, and South America, they're not as busy. They are like least busy regions. Cool. So which instance would you like us to have a look at? So I have the queue right here.
SJC, baby. Let's go. Let's go big.
SJC, baby. All right, let's see that. So I'm running flyctl SSH console. I'm using 2 flags, -s, which is a short one for -- select. It will prompt me which instance I want to select. And then I have -c, capital C. It's different than lowercase c. They do different things. I give it the command to run. And it's varnish-stat -1, which will give me all the statistics from Varnish at a point in time. So since this instance was running, I will select SJC. There you go. And it will give me all this data, which is like all the counters that Varnish is incrementing, is keeping track of different things, of the origins, backends, the memory pool, the disk pool, the log counters. There's so much stuff. I'm really, really impressed how many things Varnish has. So this is what we're going to do. Because AI, right? We're going to copy all of this and we're going to ask AI what it thinks of this. How about that? Okay. It's just too much data here. So let's be serious about it. So question to you, which is your favorite AI, Jerod? Which one do you use?
Oh, I don't like any of them. I would probably start with Claude and then I would go to Grok and then I would go to ChatGPT third.
Okay. So Claude, which one, which version, which model?
Opus, man. Give us the Opus.
Opus. Okay. So we're looking at abacus.ai, something I've been using for a long, long time. It allows you, I'm only paying $10 per month for it. Not sponsored, not affiliated in any way. It's just something that I've picked for myself and I can basically pick any model and I can just run this. So I have something prepared. So I'm going to drop this. It's all the data and we're going to read through something that I prepared ahead of time.
You pre-prompted this.
I pre-prompted this, exactly.
Okay. This guy's been engineering this prompt for weeks.
Exactly. Not really, but
that's a long prompt.
So we're going to read it. And in the meantime, Adam will think about his favorite LLM to try. And I have mine. So we'll try 3 LLMs to see what they say. So I'm going to read the prompt now while everybody thinks, no, you should be using whatever LLM you should be using. You are a Varnish 7 expert. You need to prepare 4 distinct responses and be explicit about the person that you're addressing. 1, a seasoned sysadmin that has been living and breathing infrastructure for the last 20 years. Be precise, think deeply, and approach the setup from a hardware perspective. 2, an Elixir application developer that embraces Erlang's let it crash concept. You need to give it straight, give it fast, and keep it relevant to their application. It's the app and the nightly backends. Assets and fees are important, but less relevant. Cloudflare R2. 3, the business person that is selling this thing. They care about cost, efficiency, and simplicity. Keep it high level and relevant for someone that doesn't care about the tech, but cares about the outcomes. And 4, the audience of a podcast where this is being discussed. Make it general, relatable, and fun. Make analogies, keep it light, and engaging. I have fun too many times. We don't want to make it too fun.
That's,
right?
that's a lot of fun.
So yeah, that's too many. There's one too many funs.
That's right. Well,
now that you understand your audience, please analyze the following varnish stat output for the SJC. Look, I already knew that you would pick.
How'd you know I'd go for the big one?
I have no idea. Focus on things that work well, things that could be improved, and anything else that you find interesting. And by the way, ignore the synthetic request. It will keep mentioning these like, I get so fed up with this. We have health checks that run every 5 seconds, so they are normal. So
okay,
I'm going to copy this. I'm going to run this, and I'm also going to open a new window for Adam. So which LLM should we pick, Adam? Which is your favorite?
You mean model?
Model, yeah. Which model?
We just used it, but I'd probably back up to like Codex.
Codex,
which is like GPT-5 latest.
GPT-5.1.
5.1, 5.2.
There you go. So GPT Codex. My favorite one is Gemini. So I'm going to drop it. Now let's see how do they compare.
Gemini, you're in a different tab now. So Abacus can't do Gemini?
It might, but I have like my own pro account. So gotcha. That's something else. Like I use quite a VO. I use Nano Banana, quite a few things. Transcripts, it's all like part of the package.
Sure.
So it can, but that's what I prefer. Cool. So Claude Opus 4.5 for the season sysadmin.
This is you.
This is me. This is me exactly. Yeah. Thank you for noticing.
You're welcome.
For like who's who.
I'm following.
So what's working well? Rock solid stability. So by the way, the instance has been running for 5.4 days. We had like all these improvements shipped, and we are able to observe how our busiest instance works. And that's what this is basically. That was the window moved. Cool. So after 5.4 days, 0 child panics crashes, 0 thread failures. This is important. It means no threads died, no threads had to be restarted. Everything is healthy on this instance. It didn't crash. So this instance didn't crash. 0 lock contention across all subsystems. Your CPU cache lines are happy. Excellent hit ratio, 93%. We like that. We really like that. Mm-hmm. We have backend connection pooling with a 2-to-1 reuse ratio, and memory pressure is minimal. 132 LRUs in the last 5 days. LRU nukes. So very few objects had to be removed from memory. Thread pool property, 300 threads, 0 queuing, 0 drops. That's perfect. Areas to investigate. Disk storage allocator failures. We have disk C fails. We are hitting storage fragmentation. The disk is 97% full. We have 48 gigabytes used. Mm-hmm. That's how many MP3 files are stored. By the way, how many MP3 files total do you think we have?
Size or file?
Size.
Well, if we had 1,000 episodes at 100 megs each, which neither of those things are true, that'd be 100 gigs, right? So 100's too big, but 1,000's too small. I'm going to say 80 gigs.
Adam, do you want to guess?
That math checks out. I was going to say like a terabyte, but that's probably raw wave files versus not. But
all the files that we store in R2, and this includes all the assets, but we know that the MP3 files are the biggest. It's close to 250 gigabytes. We may have some duplicates. I don't know. I haven't checked. But that's how much files we have in R2.
Yeah, well, we also have plus for the last couple of years, which means every episode has 2 files, not just 1. So that makes sense.
So we should go higher. Now, we use this in every single region. So maybe we want to reduce number of regions. But I think...
You need a third category called super hot.
Super hot, yes.
Which is like SJC in Tokyo, right?
That's possible, yeah. There's 4, which we know they're really, really hot, yeah. Yeah, but honestly, this is happening across multiple regions. And
it is.
We'll get to some interesting things. So, okay, synthetic responses, grace hits, all good. For the Elixir developer, and I think this is you, Jerod. Do you want to read it out?
Oh, well, the TLDR is Varnish is doing its job. Your app backend is well protected. You want me to read the whole thing?
If you want. I mean, how it's shielded.
It's 95% shielded. No failures, 0 backend failures. That's because of, my code doesn't really let it crash very often.
Exactly. Your code is, it crashes internally, not externally.
That's right. My thing is doing its thing.
Mm-hmm.
It is generating some uncacheable responses, but, we do have some that we just don't want to be cached. Ooh, one fetch failure, negligible. Yeah, I agree. You don't need to worry about that. And in the end, it says whoever wrote this is really good at what they do.
I agree.
And
that's exactly what it says.
And congratulations on such a great hire.
Yeah, I agree. I think the hire needs a promotion and a bonus. I think.
There you go.
All right. For the business person, the caching layer is performing excellently. Adam, do you recognize yourself? Or shall I continue with this?
You can read it.
93% of requests never touch your servers. Massive cost savings on compute. Do you know how many requests per second the application is serving? Like maximum, by the way. What's the maximum RPS for this amazing Elixir Phoenix application for the homepage?
Probably a lot. Gosh. Thousands? Tens of thousands?
Maximum. Okay, Jerod?
100,000?
The database connection is involved.
Concurrently?
Concurrently, yes.
I don't know. I'd say not very many. To our homepage? I'd be
The
like
homepage.
12. 12 requests a second.
Yeah, 17.
17. I'm right in there, baby.
Someone that knows our code. So 70 requests per second. So if all these requests were hitting the application, we would need so much compute to serve that. So much caching. Obviously, we've removed all the caching now. We're joking about this because we purposefully removed all the caching from the application.
Right.
I remember that a couple of years back because we said this has no place in the application. The application gets restarted.
Yeah.
We need to store this somewhere. We need a cluster. It was just really messy to handle it at that layer, which is why we introduced this. 5+ days running without any issues. By the way, this is like the last deploy. So maybe by the next Kaizen, if we do no more deploys, we'll be able to see how well it handles. 0 failures on the infrastructure side, and 3 terabytes of data served to users. 3 terabytes. So in 5 days, this one instance served 3 terabytes. Without your application servers breaking a sweat, storage is getting full. So we need basically more storage. For the podcast audience.
Oh yeah, that's gonna be fun.
Imagine a really good receptionist at a busy office. This Varnish server is like having someone at the front desk who remembers everything. Out of 100 people who walk in asking questions, 93 of them get their answers immediately from the receptionist without ever bothering the experts in the back office. What's cool? It's been running for over 5 days straight without a coffee break or a single mistake. That sounds cruel to me,
Good
but
job.
let's go with it. It served 3 terabytes of data. That's like streaming about 1,000 HD movies. This one instance streamed 1,000 HD movies in 5 days. And the experts had only had to answer 7% of the questions. The one quirk, the filing cabinet is getting full. It's like when your receptionist's desk drawers are stuffed and they occasionally have to throw away old notes to make room for new ones. Not a crisis, just time to get a bigger cabinet. Okay, I think the fun stats, the 300 workers, I think that's too detailed.
That's good fun there. Good job, Elmar.
Yeah, I'm just...
Do we care about GPT or Gemini? We can only use one. We can only pick one.
Gemini's getting some good hotness.
Let's check Gemini. Let's see how it adds up. Oh, it's still thinking.
Let's see. I think it finished. Maybe that's... let me just close that. Did it finish? I think it did. All right, so let's go up. Slow thinking. I did like the thinking. I could have gone pro as well. Gotcha. Show thinking.
Oh, show thinking.
Slow thinking.
I thought it said slow thinking. I was like, come on, speed up, Gemini.
Show thinking. Yeah, there is quite a lot there. Anyway, we're not going to look into that. So
no.
The instance has been up for 5.3 days. The MGT uptime, I like it. It's telling me which of that long list of counters is important. From a system perspective, the threading model is perfectly dialed in. 300 threads across 2 pools with 0 threads limited and 0 thread queue length. The kernel isn't context switching unnecessarily, and we aren't starting for execution units. However, we have a critical I/O and storage allocation bottleneck in the SMF, the file. I'm not sure what Steve Dorr means. That's a weird one.
I'm not sure Gemini knows what Steve Dorr means either.
The problem is SMF disk C fail is at 19,000 plus against only request that is 73% failure rate for disk allocations. The G-Space, in the G-Space, we have only 145 megabytes, while we have 48 gigabytes used. you're effectively out of contiguous blocks or hitting the ceiling of the pre-allocated file. That sounds right. Varnish is forced to fall back to SMA RAM or simply not cache large objects. While SMA has 2.1 gigabytes free, the disk is thrashing. The hardware, if this is spinning glass, your I/O weight is likely spinning. It's not. It's NVMe. So yeah, there's quite a few things there. Interesting. Is low relative, suggesting the lock contention on the shared memory log is negligible. Nice. We have low lock contention. The bottleneck is strictly at the storage layer. We just need basically a bigger disk. The Elixir developer, let it crash proponent. I like it. Your app backend is rock solid. Well done, Jerod. Varnish hasn't seen a single backend fail or an unhealthy event in 5 days. The let it crash philosophy is working. If the app is crashing, it's recovering so fast, Varnish doesn't even notice. I don't think it is. I think the application is good. The good news is we're seeing an effective 75% hit rate. Now, this is different, right? We had 93% there. So I would like to understand the discrepancy. That's another reason why you should use more than one, by the way. And then obviously double check the data because sometimes they give you things which aren't true. The crash concern, the disk cache is crashing. Again, this is not for the application developer. I think this is for the sysadmin in me. I think the straight talk. Your main synth is high. So we have health checks. There's a delta responses. So we have a lot of synthetic requests again. Synthetic responses. This is again like a Varnish thing. The business person, efficiency we're currently serving of our traffic from Varnish. I think I know what's happened. I don't think it's taking into account the synthetic requests. Those should be removed from the total number of requests.
So you think Claude has the right number?
I think so, yeah. Yeah, I think so. This means for customers, we have cost efficiency, that's good. The risk, there's the bottom line. I think this was the fun. But I think this is a library. I think we can stop it here.
Use the library analogy versus the secretary analogy.
I think that was a better one. I got a barista one. I thought that was like a very good one.
Oh, yeah. For queuing or for what?
For queuing, yeah.
Yeah.
Like the barista analogy I thought was very good.
Yeah.
This is using books and whatnot. The library hasn't burned down. That is fun. Good thing. That is fun. So I think Gemini is getting a bit funnier. The nightly feeds and the app are still humming along. Nice. So that's what we have. And that was only half the problem. So we're like at the midpoint.
I was feeling good. I feel like we had it all fixed. What else is the problem?
Oh man, this is like when all the fun begins. So you remember this, Jerod?
Yes. MP3 requests intermittently hang in Newark, New Jersey. This was our good friend John Spurlock, who's been on the show before and is a podcast nerd. In fact, he runs op3.dev and other podcast nerdery things. And so he really knows his stuff. And so when he reports issues, I don't say, did you try rebooting? I take it seriously. So I shared it with you and he actually did some additional digging for us. Go ahead.
So in terms of, you tested this and I think you had issues as well. So we've confirmed this for sure.
I did. Like certain times, certain files. Actually, it would be all requests at certain times. I assume that it was that particular pop, as we could call them, or pipe in the Pipedream, was hanging. And then it would go away. And he actually had the same problem. He had a Friday night deploy of Friends, and he was trying to listen to it on Friday, couldn't get to it. By Saturday morning, he can get to it. So it's intermittent hanging, very difficult to diagnose, very difficult, I assume, to debug. And then it just comes back to normal. I thought it was maybe the out of memory thing, like it's just in some sort of fugue state until it reboots and then it works again. But you go ahead.
That's what I thought. That's why I did like a deep dive on this. This was November, end of November, beginning of November. So November, I was just trying to figure out what on earth was going on. Just like, like from the sides, I didn't have too much time. But if you look at this response, there's quite a few things there. This is like my initial one, like an investigation, trying to understand what's happening, giving a couple of debug headers, like a couple of extra headers that the request can be made of, can be run with. So we just get a bit more details. Forcing regions as well. So there's quite a few things there. I was checking into that. This is Don McKinnon. He also had issues today. So he pasted some results. So thank you, Don, for adding this. This was helpful. So it's long. I'm still scrolling. There we go. Super helpful. I've confirmed that the requests have been hanging. You are getting the hangs this afternoon as well. This was only 3 weeks ago. So this has been going on for a while. I dug deeper and I found the problem. The problem was that in the fly config, we had the concurrency set to connections, not requests. So it's possible to configure an application. Again, you're configuring the fly proxy that sits in front of the application to limit how much traffic hits your application. So requests, how many requests per second should the fly proxy forward to your application before it stops? Because you don't want to get overloaded. Right. So before it starts throttling, it starts slowing clients down. And then when you start, that's when you start seeing fly edge errors. Connections you would use for something that has long running connections, like a database, for example. In our case, is not a database, right? It's an HTTP application. So requests would have been the right concurrency. I have no idea why I picked connections. It was the wrong one. But the effect was, as you can see here, we had 2,700 long running connections on that edge, so on that region. So in this case, it was, I think, orange one, I think EWR, right? So EWR had all these connections opened. The clients weren't closing the connection. The proxy was full. No more connections could be forwarded to the application. Long running connections, there are usually clients which are not doing the right thing. Right, you shouldn't have that many long-running connections. So the problem was a misconfiguration on our side, which meant that connections like slow connections, long-running connections were basically blocking other connections from coming through. So that was the problem there. And I thought that was it, but there was more. So this was the last comment last week. We now have a check that runs every hour. And what was interesting, and I'll talk about the check as well, we had response bodies timing out in 2 regions. So 13 regions were fine, but even after this configuration, there were 2 regions. I had an EWR where when we were using HTTP2, and for some reason this is important, when we were using HTTP2 and the fly proxy would see this, it would not forward the connection correctly. As in, it would serve the response, we could see the headers coming back from our instances. What we wouldn't get is the body. So the body would always be 0 bytes served. And we could see this happening. We could see the connections that, by the way, they were opened. They shouldn't have been opened because the application changed. So these connections should have been dropped. There was something not quite right. My suspicion is with the fly proxy layer, because when we were forcing HTTP1, everything was working fine. And by the way, the fly proxy, when it talks to our Varnish instance, it's using HTTP1. And you can see that in the headers. So the proxy to the Varnish was fine, but the client to the proxy was not fine. And HTTP 2.0 is a very complex protocol. There's so many things which just don't work the way people would expect. So anyway, the issue fixed itself. That's the important thing. So opening
not super
this,
satisfying.
Yeah, that was very nice to see. And there was something, mayailrus. How would you read this?
mayailrus.
Ilrus. There you go. So there's someone on the Fly community forum that was very helpful. They noticed that we had a misconfiguration in our Fly TOML. And we were using services as well as HTTP service. And this is bad, by the way. This is very, very bad. So everything was happy. We could push this config, the applications were running, everything was fine. But because we had these 2 things together, it was apparently creating some issues. And all we did, we were explicitly setting the idle timeout. And the idle timeout, that's the one where if after 60 seconds, the connection isn't doing anything, it will be forcefully terminated by the proxy. So that part was important. So anyway, we made the change, we pushed the change, but even before we pushed the change, the proxy started behaving. And now there's pull request 49 has like, we right-sized it. We made a few changes. I captured like all the details, the configuration, the commands. It's all there if you want to read it. But most importantly, now we have a check that runs against all regions every hour on the hour. CI/CD, it's using curl. And what I'm thinking is, shall we try running that locally to see how it behaves? Because that's how I started it. Like I was starting to do it locally.
Yeah.
So on the left-hand side, I'm back in the terminal. On the left-hand side, I am monitoring my internet connection. Remember that Christmas tree? This is related to that Christmas tree. So I'm at the top of the Christmas tree. I'm at the gateway, the core router. It's a MikroTik CCR 2004. Pretty good. 10 gigabits per second maximum. Now, my internet connection isn't 10 gigabits, but it's 2.5, which is plenty for this test. So every second is showing me how many packets and how many bits we're receiving and transmitting.
Okay.
And again, we are recording, everything's happening live. So you can see it jumping right as Riverside, we're pushing more data to Riverside. Cool. So I'm going to run now, just check. And just check by default, it's one of the commands, the just command that we have in the Pipedream repository. And check, all it does, it runs curl with a couple of flags. It downloads an MP3 file. It downloads feeds. It basically connects to all the different backends and it sees how quickly it can get data back. We're transferring about, that was quick, that was 8 seconds. I'm going to run it again. As I run this, pay attention to the left-hand side. It will go to 120 megabits per second. So that's that MP3 file being downloaded. So every single time this runs, a full MP3 file gets downloaded alongside a few other things. Okay, I can open the reports. We're not going to look into that because we're going to run something more interesting now. We do check all. And what check all does, it runs the same command against all the regions. I'm at 2.3 gigabits per second. We're downloading all the files. We can see the response is coming back. EWR just sped by. I had sped by. So all the different endpoints are returning. Now I'm based in London. Obviously, the further away you are. So for example, this was South America, those LAX. So a couple of instances are slower to respond. And all this happens via headers. So you can, when you connect to Fly, you can tell it, hey, I want to connect to a specific region. And then that's what routes the request to that region.
That's cool.
And again, it's all captured in that pull request and you can see what it looks like. The check call one, Johannesburg, that's usually slow. And the slowest one is Tokyo for me. Sydney as well can be slow. So we still haven't received responses from there. We should get that shortly. You can see I'm pulling now 50 megabits, 20 megabits. It's just slowing down. And it's just the connections between now and there. The last one, there was Tokyo. In 60 seconds, I pulled about 2 gigs, roughly. It's a lot of data that gets pulled down. The feeds between all of that. And anyone can run it. I would recommend you not to run this because we have to pay for this bandwidth, but our CI runs it just to make sure that everything works. And if we look at every hour, I think I'm going to tune this down. You can see there were no more connections hanging. So we got to the bottom of that as well.
If it ever comes back, because it went away on its own. If it comes back on its own, we're going to know about it.
Exactly. Now we have a system that is able to inform us when there's a problem. So let's go to 3. We're on page number 3. This one, for example, took more than 5 minutes, right? So sometimes when the connectivity is a bit slow, some regions can be slow. That's when you get these timeouts. So this is capped at 5 minutes. The last one that failed was a while ago. So you can see we're January 5th. There we go. There's one that failed January 4th. Check all instances. So let's see run and we'll see exactly which region failed. Execution, NRT, that's Tokyo. And as you can see, we have 100 seconds, right? So if after 100 seconds, it doesn't download, it just times out. And we were pulling data, but it didn't finish downloading the entire MP3. And we're downloading 100 and something megabytes.
Very cool.
So,
I mean, not cool that it didn't finish, but cool that was a while ago. And
yeah,
we can actually test this. Now, do we need to be doing such a large file? Is that part of the test? Or could we test a smaller file and still get the same results?
We could. Yes. This was the file that was reported. So we need to find an MP3 file Absolutely. I think we can also reduce the frequency. We don't have to run it every hour. This was obviously in preparation for this conversation.
What about episode 456? That one.
That's coming up. That's the deepest rabbit hole. So I'm leaving that. I'm leaving that for last. That's coming, Adam.
One thing I suggested though in our Zulip, and I don't think this is. I didn't check to see if this is even a thing, but to validate, if the fly CLI could validate the TOML file for you, because you could have checked the TOML file for syntax errors or just do's and don'ts essentially, and it didn't.
It does have a validation subcommand. Syntactically, it's correct. The config is valid. I mean, it was applied, but because it combines two things, it shouldn't. So at least I would expect a warning, like, hey, you're using both HTTP services.
Right. Yeah, validate syntax and then validate, expected, true TOML file config. Yeah. Don't combine or conflate two values or overwrite one or, just that kind of thing. That's how I would defensively do something like that in a CLI to protect my user from a poor config. They could have just not been holding it wrong for so long. Yep,
I agree. This is the impact of that configuration indeed, yeah. So this is something we can see again, the same logs. We can see this one here, we go like to 50 megabytes per second. That's 500 megabits. When we have these peaks, when we see this in the fly config, we can see this usually when the benchmarks run or like when the checks run, because they put significant pressure on the instances and we can see them. We can pick them up straight away. So that's what this is. All right. So remember this guy. This guy was saying March 29th. So it's almost 2 years ago when this guy was saying, we will run into all sorts of issues that we end up sinking all kinds of time into. So this guy had a good hunch. This is Jerod, March 29th. And we just went through a couple of examples of issues that we had to deal with, part of this. But because of this, we understand the traffic and we understand how the application behaves and the backends behave at a very deep level. So you're right, Jerod. We did sunk all sorts of, how many lines? Let's see, how many lines do we have now? So how many lines?
I wanted 20 lines.
590 lines.
Oh.
590 lines we have in total of Varnish config. It's more than 20 lines. By the way, we have like the roadmap to 2.0. This is 1.0 that we tagged and shipped. It's solved like a lot of issues. But that was the easy stuff. Okay, so for everyone that stuck with us, something really good is coming up. And Adam was already mentioning it, episode 456. There's something special about episode 456. So what is special about it? What stands out to you, Jerod?
Oh, it's just getting rocked with downloads.
So episode 456, OAuth, it's complicated, was down. By the way, this was recorded in 2021. It was published, again, August 2021. For some reason, it's been downloaded a lot in recent months. It has over 1 million downloads. This is the most popular episode on the changelog ever.
The most downloaded episode.
It's crazy. Yeah. It's crazy. So
you guys looked into this?
We did, yes. We dug into this.
Okay, I didn't know you guys were doing this.
So we just had a quick look to understand what is happening here. So we have Honeycomb open up. Remember, every single request which comes through the Pipedream, through Pipely, every single request we send to Honeycomb, we're able to look at it. This is the last 60 days, and I have filtering done in such a way so that I'm only looking at this one file. How many times has this file been downloaded in the last 2 months? And you can see the peaks, right? You can see, and by the way, this is gigabytes. So, and this is, the period is 4 hours. So we are peaking at about 100, well, actually, there was like, this peak was here. We had 200, almost 300, 400, anyway, close to 400 gigabytes in a 4 hour period.
That's just too much.
I think so. Like, I know this is a great episode, great conversation, but
I remember that conversation. It was good.
Like, who is downloading this file 400, times, or actually more than 400 times every 4 hours consistently for months on end? And
super fan. Some sort
a
of
super fan. So we can see like the different regions. Now, this is spread across the entire world. It's not just one region. This is really, really big. I think if there was a DDoS attack, I think this would class as one. And like in the last 6 months, in the last 2 months, 60 days, we served 30 terabytes in San Jose, California alone. In Tokyo, we served 15 terabytes. This is a big number. And if you look in this column, the distinct IPs, the client IPs, we had over 10,000 IPs downloading this file. So this is not one or two IPs. This is thousands and thousands of IPs which keep downloading this file over and over and over again. So I don't know how we would block 10,000 IPs.
Right.
That would be the VCL would be crazy.
Well, that episode was starring Aaron Parecki, who is a very talented person. And he is the co-founder of Indie Webcamp and a big fan of the Indie Web, as well as OAuth, obviously. So my hunch is Aaron's very interested in being the most downloaded episode ever. And he controls a fleet of machines from all around the world. And he points them wherever he wishes. And he thinks, you know what I'm going to do? I'm going to get to the number one spot on these guys' download charts. Mm-hmm. And so I'm thinking Aaron Parecki is, the man with the mask on. We pull the mask off. And it's him this whole time. What do you think, Gerhard?
I think that we need to speak. I don't want to say the specific language. I think we need to go to Asia. I think we need to visit a couple of cities in Asia.
Okay.
Find the IPs which are responsible for this, because this is a crazy amount of traffic. Asia, it just so happens, if we look at, so Asia is basically the continent where we are getting the most downloads from because of this one episode. And this is actually traffic being served. This is not like head requests or get requests. These are bytes being sent to thousands and thousands of machines in Asia every single hour. So whoever is doing this, please stop. Please.
It's on a cycle.
So we need to knock on doors. We need to go over there and knock on some doors and say, excuse me, is this IP address at this home? And then they might say yes and say, would you please stop? And what's going on over here? What could they possibly benefit from this? What could they be getting?
Maybe we're the speed test. Someone is using us to speed test their connection. Who knows?
Yeah, maybe.
That's the only thing I can imagine.
Well, that's a lot of IP addresses.
It is.
And it's across multiple regions,
multiple data centers, yes. So multiple regions, fly regions are serving these IPs, yes. They're all coming from Asia, by the way. Again, I don't want to mention any names because there's no bad guys here, right? We just want to assume that someone left the oven on.
I don't know, man.
It's like the blinker on when you're driving the highway. It's like, hey, you're not turning. It's time to turn that blinker off.
So the way I can see us mitigating this, and this is a hard problem because of the number, right, of IPs which are hitting, is we can basically start blocking entire net blocks, entire network blocks. Unfortunately, some genuine listeners might be caught in this, and basically a changelog will not be available, or at least the MP3s will not be available to a portion of users. The other one is obviously we should, right? This is like the next problem. We should enable some throttling because there's more stuff happening here. So we don't have any sort of throttling. We assume fairness. We're assuming goodwill. We're assuming decency, and we're not seeing that here.
Well, that's the internet.
So to be honest, whoever is doing this, and it's not LLMs, I had to look. We have that problem as well, but in this case, it's not LLMs. This is something completely different. So my hope is by someone that listens to this episode, maybe we put this in the intro. Whoever's downloading episode 456, please stop, because we'll need to take the next step. I know it's a bit of a cat and a mouse game, but that's what will need to happen because we need to pay for this bandwidth.
This is only varnished, right? This is only the cache layer. This is happening.
This is only the cache layer, yes. Yep.
And so what mechanisms are in varnish to do throttling or rate limiting or just anything like that whatsoever?
There's vmods, which are basically modules that varnish loads that just give it extra functionality. One such vmod, and I've looked at this, it is free and open source, is the vmod throttle. Now that means that we need to start keeping track of IPs, and it will use a bit more memory. That's okay, we have more memory. And then we can need to start basically applying limits to how many download specific IPs can do. And we can limit it to MP3 files only. So if we have a bot, or if we have, for example, like, I don't know, an RSS aggregator or something like that, we're okay serving those requests, because again, that's what Varnish is meant to do. The problem here is that we're serving a lot of bytes for MP3s, the same MP3 that cannot be real traffic.
Yeah, I mean, even in this case, you can like tie it potentially just to this MP3, like you just said, which is not an all MP3 scenario. Like if you request this MP3 with this kind of like request signature of X per whatever. I mean, I didn't examine the actual signature of the request, but that's how I'd probably investigate it, is begin to isolate.
Yeah.
Does that require us to write a lot of defensive code against that kind of scenario?
I don't think so. It's just some configuration. We just need to add more configuration. And back to Jerod's point, we're just chasing now new problems that we didn't even think we would have. But we have what looks to me like an actor that's not very, I want to say this in a nice way, an unfriendly actor that is not very happy. And they, are very angrily downloading our MP3 over and over and over again, thousands of times across thousands of IPs. And this is not cool, because ultimately we end up paying for this bandwidth that is not helping anyone. But that's one. It's not the only one. So we have one more. So you can see here, for example, this is the last 7 days. We have 7 terabytes that were transferred in the last 7 days. 7 terabytes? Maybe that's more than that. It needs to be more. And did I actually... Geocode does not exist. Okay, I was expecting to see more than that. Anyway, Asia is the one that we can see like that pattern, but we also have like in Europe, sometimes we have these spikes, and it's like this spike which I wanted to focus on. We know that someone in Frankfurt that connects to Frankfurt downloaded the static favicon 170,000 times in the span of, I don't know, like an hour or two. So they downloaded this like 2-3 hours. So we get, requests like this that are putting stress on these instances. I mean, what potentially, and that was like a past request as well, which means it like went through the cache, which means that they must have had like a cookie set up or something like that basically was preventing the cache from working in this case, which again, that's how it's supposed to work. So anyway, I think that was unfortunately not the best thing that we could have ended on, but it's a thing. And it's something food for thought, like more work to be done. There's many things that we didn't get to talk to. We didn't have time for. For example, we didn't talk about the nightly. By the way, nightly now is being served by the Pipedream as well. And the reason why we had to do this, because that sometimes will get scraped, would get hit really heavily. It's a very small app. It's Nginx. But if I open it, so let's just click on that one. And that's pull request 46. Before, it was basically topping up at 141 requests per second. Now it's 1,300. So it's almost like a 10x, an order of magnitude faster. The latency went way, way down. So, and it's just the only thing we had to do is basically put Varnish in front of it.
Nice. Well, that's nice.
Yeah, that's one more thing there. And you can go and have a look how it works. I did like a benchmark here, a small benchmark here. That's it. We have last one for the road. But before we do that, anything else that we want to talk about before I share one last thought?
I suppose, what do we do? If we know these demos are happening, we're here on the podcast just politely asking to stop. We just let it keep happening?
Well, we could set up some sort of throttling. I think it'll be the easiest thing. Now, it will impact everyone. I don't want to start blocking, again, IP ranges, net blocks, because we don't know who's going to be caught there. They may change to other IP blocks. So that's entirely possible. We don't know how this will work. We can't block an entire country, an entire continent, especially if it's a big one.
Gosh,
I don't think that's reasonable. So really throttling is, I think, the fairest thing. And then we can throttle MP3 specifically. Because we do have, for example, I see them, like, for example, we have a Python client and a Go client that every week they come and they download all our MP3s. I don't know why they do that, but every 7 days, they basically request every single MP3 that we have. So they're like scraping the website and then pulling everything down. I don't know why.
Yeah.
again, the closer, like the more I was looking at, and again, because I was working so deep in this, I started noticing like these behaviors that you would normally not see. So it's one of the advantages, I suppose, to working so close with the traffic, with all the requests, and having this level of understanding and visibility into every single request. So it really helps down to the IP level.
Something like that, though, like the Go client and the Python client, where would that be a honeycomb thing? Where would that be?
Yeah, it's honeycomb, yeah. You can filter by user agent, for example, and you can see that like there'll be on, for example, say, now I don't want to show any IPs or anything like that. So that's why I'm not going to screen share that.
Yeah.
But once we start digging into that, you can say group by client, agent, and you can say filter by MP3s. So like URL contains MP3, and that will be able to group. And you can say, oh, and by the way, only show me where there's more than, for example, 100 downloads. And then you'll start seeing like the outliers, which are the clients start downloading certain MP3s or MP3s in general excessively. Now, that can be spoofed. That's the other thing. Like we have, for example, the request agent, like the user agent, it's empty. It's an empty string. That also happens, right? Because you don't have to send the header if you don't want to.
Yeah, you can also send whatever you want.
So that can be spoofed.
Yeah. It's like whenever you build systems like this, and then even when you observe them, I guess you don't expect, that's what I originally thought, but you kind of hope that clients, aka people, behave. They're going to use the system for the system's purpose, not to once a week download and scrape the entire thing. And I mean, in that case, somebody could have their own web archiver and they could have altruistic reasons for it. I think that's kind of silly, but once per week, download the entire contents in somebody's disk seems like I want your thing. I want to keep getting your thing. And if it ever changes, I want to make sure I have that snapshot. I don't understand it. It doesn't make any sense. Like, what would make anybody do that? What is the purpose and motivation to keep doing that? Mm-hmm. To even commit the compute or the script or the time to do that? Like, what are they getting from it? I don't know.
We need to go over there and knock on some doors, man. We got to ask them.
Yeah.
Why are you doing this?
Every door
for you
in Asia. Do you listen to the changelog? Yes, I do. How many times?
Yeah.
Tell us about 456. You know what 456 means, don't you?
Yeah. It's just, see, this is how, so this is, I think, a really delicate and a really important point to discuss, because this is how good systems become bad systems.
It's true. Yeah. You have to treat everybody bad.
Exactly. Like we don't want to be doing this, but we are forced to do something against something which isn't good. So it's not benefiting anyone. And we have to step in and do something about it. Now, we have to do it. It's been like, I was expecting this to stop, but it's still even to this day. We made Varnish. I mean, now that it's stable, it's able to serve more traffic. It's able to, like, we just had like the biggest spike because now the system is more stable. But it means that bad actors, again, I shouldn't be using that. Unhappy people, unhappy clients.
Use it.
Unhappy clients,
The only person you can offend is the one who's doing this, and I'm fine with it.
Yeah.
They need to knock it off. Here's this might be a cudgel. But if we're trying to solve the problem of they're taking our bandwidth for something that's no longer relevant or interesting and it's been out there for years, what if we could just toggle certain episodes? And this might be a cat and mouse game as well. But like at a certain point, it's like, well, just give them the R2 URL and not the CDN URL, and just let Cloudflare deal with it. Like just let them download it directly from Cloudflare, and we're just out of the equation then. We don't care about the stats. We don't care about anything. We're just like, we've served this file plenty of times through our CDN. Now we're going to just let R2 serve it. What do you think about that idea?
I can see for this specific episode being a very simple fix, right? Because we can just serve basically a location header and we just do redirect, and that's it. We're done with it. So it'd be like another synthetic response. We could do.
The question is, if they're actually malicious, then they switch to a new episode and start doing that one.
Exactly. Right? Exactly. And we have other clients, which are, for example, we've seen that pass, right? They're basically busting the cache and purposefully going to R2 directly, and just Varnish is like a almost like acts like a proxy in this case.
Right.
So we have that as well. We have every now and then we have like this random client that comes and downloads all the episodes, and that's not the problem. So I think that some sort of a throttle would make sense, which would keep the system fair to everybody. But the throttle will need to be high enough so that it doesn't impact anyone else. Now, if, for example, our requests or like if our audience grows or we become more popular and we get more requests, obviously we would need to be aware of where the limit is and start increasing the limit, right? Once we are throttling too much, maybe.
Mm-hmm.
But that seems to be more like long-term, and it seems a more, I don't know, like a well-engineered approach in a way. But certainly the simplest thing would be just like take this one URL. I mean, that could be done in minutes, roll it out, and then we would stop this abuse for this specific MP3. That would be the easiest thing for sure. So yeah, I can see how pragmatic that approach is, and I like the pragmatism.
Well, it's at least worth checking to see if, the mouse is still alive over there.
Right. Yep.
And if they are, then we'll know that this is a cat and mouse game. But if it's just like somebody left the blinker on, we're just going to turn their blinker off for them.
Yep.
And see if the problem goes away. And if it changes to a new MP3, then we need more generic solutions.
Yeah.
We may not need that at all.
I do have to say that the internet these days is very different from the internet even like a year ago. With the rise of LLMs and AIs, I'm starting to see patterns in our traffic, which are unlike any other time. We have these very big spikes when a lot of data is being requested in very short periods of time from, the user agents, they don't make much sense. I know they're spoofed. There are many IPs which are being used. So it's almost like there's like some system which wants a lot of our content is doing silly things because some requests, they just don't make sense. Like for example, what benefit does static favicon have? Like what's up with that? That just makes no sense.
It's a small file. Maybe it's a heartbeat or a version of a heartbeat.
Maybe, but this is the first time I've seen this specific file being downloaded this many times. I haven't seen this before, which makes me think, is this a trend that we'll start seeing more and more requests that don't make sense? And then you start having to set up like some form of protection for all sorts of clients that are just doing the wrong thing.
You need like a defensive layer by default.
Exactly, yeah. And something that would be fair to regular clients, like for example, when I do like a benchmark, sure, it's me, and I wouldn't want other people to do that because I'm testing the system, making sure like the real world, the production system everywhere in the world is working correctly. And I'm aware of what that means and how it costs. And by the way, my IPs are removed from all like the stats, because otherwise you see like those massive benchmarks. So we account for that, but we can't account for all these like weird clients. It's a challenge. I think it's a good one, but it just sets us up to, when you become older, it feels like this like more like often like an adult problem, right? So we like got the thing barely working. We got it out there. We made it stable, reliable, all of that. Now we're hitting almost like feels like a new layer of problems. And this to me is like a hint as to like the next phase.
Oh, to be a kid again.
Yeah. Well,
right.
One positive thing I think is the robustness of our observability. Like being able to have this visibility is great, because otherwise we're like, wow, pat ourselves on the back, Aaron Parecki, let's get you back on the pod because, man, you are big all over the world. That's amazing.
Big in
1 million
Asia.
downloads,
Yep.
So what's your one last thing for the road ahead? I agree. That the observability.
What's my one last thing?
Yeah.
So keep it short. We'll keep it fun. I mentioned about the Christmas tree.
Mm-hmm.
I mentioned about the various things which I had going over the holidays. So Make It Work Club, that's the place. You're there. Both of you are there. So you can join whenever you want. Next Thursday, I'm going to talk about the 100 gigabit WAN. The 100 gigabit WAN. So why would I need such a thing? It's smoking for sure. So I thought the CCR 2004 has like 4 CPUs, has like multiple 10 gigabit SFP plus ports. It even has 24 SFP28 ports, but it doesn't have a switch chip. And people that know about a little bit about hardware, you want to switch chip to the hardware offloading L3 and even L4. So after I bought the CCR 2004, it was like almost like a Christmas present. I thought, surely this will be enough for the rest of my life. And no, I had to get the flagship. So I'll be talking about that, the LAN, the setup, quite a few things coming up. And it just goes to show how much I enjoy the hardware side of things as well, the networking side of things. Like I shaved 2 milliseconds off my WAN. It's amazing. like little things like that, you know, like it was already good. It was like already like sub 5 milliseconds, but I wanted like sub 3 milliseconds. It's now 2.4 milliseconds. So the next, and what it means, like, why would I do this? So first of all, I'm all about improving, and every winter I improve the network. In this specific instance, I wanted the pages just to be snappier, like things to load a lot quicker, to handle a bit more traffic, but also to not have an impact. Like I was running that benchmark, like 2.5. Look, I'm going to do another one right now. Let's see. I have a speed test. I have speed test right here. Speed test, London. Let's go for this one. So we're recording, we're streaming, right? And I'm just pulling 2.5, 2.6 gigabits down. And there's no interruption on my network, right? So it's just my bread and butter. You know, that's how I work. And by the way, if you see any buffering or any slowing down, let me know. Yeah. I see Adam a bit more pixelated. Maybe you can see me pixelated too. I don't know. But yeah, I just pulled 6 gigabytes, 3 down, 3 up. And it's just what I do every day. I work with this stuff and yeah, I enjoy it. And by the way, this is the slower gateway router. So I'm getting the proper one set up, and I'll talk about that. And there's so many things there. Like VLANing is quite a thing. I have a new IPv4 block, by the way. So some would say that I'm preparing for hosting something, and maybe I am. I don't know. We'll see how that works. But I just realized that my home connection, obviously, I couldn't serve all the MP3s that were being downloaded. Like that would really cripple my connection if that was happening. But I'm at 2.5 gigabits. The next one will be 5 gigabits. And the hardware can do it. And at 5 gigabits, I mean, that's like a decent server. Sure. And if you can do 5 gigabits all day, every day, gigabits. Yeah, gigabits per second. That's pretty decent. So I'm just waiting for more internet.
I'm gonna say you're gonna have 100 gigabit WAN, but you're not gonna have a connection for it, right?
Right. So very few places in the world have that. So if I was in Switzerland, I would get 25 gigabits.
Now, would you move? Would you move for this?
Of course. The only reason. The only reason to move.
No hesitation.
It's the 25 gigabit connection. But I know that 100 gig is coming. So we'll see. They either ship it by the time I move, or I move, and then they ship it. So it's one or the other. Okay. The important thing is I have the router to handle
You'll be ready. You will be ready.
I'll be ready. Exactly. Yes. So I'm a prepper. I'm prepping for that.
Prepping for good internet.
And this is just like and interestingly, 5 years ago, when I got like the previous router, I did the same thing. It's like a forum post, did like a follow-up. So I just did a follow-up recently at this milestone. So I've been at this for some number of years, and I like optimizing my network and making sure that it's in tip-top condition.
Relentless. I love it. So relentless.
Good stuff, Gerhard. Well, that's a happy note to end on, right? That's a happy note to end on.
Observability in 100 gigabit?
No.
That's the way to do it.
All right. Well, the good news for Kaizen is we have a lot to work on.
Always.
So that's what it seems. Yeah, we know how to pick them, don't we?
Oh my gosh, the rabbit hole goes deep, and we keep going in.
Kaizen,
my friends.
Kaizen.